Lecture 17, S parameters and time average power and generalized S parameters. Right, there are two remaining topics concerning S parameters that we will cover. So the first one is the relationship between S parameters and relative time average power flow. And the second one is the generalized scattering parameters. The first one, the relationship between S parameters and relative time average power flow. Please refer to the figure. So here you have a two-port network connected to the transmission line circuit with a mesh load. So here you will have the source, so voltage source and the impedance source. So here is port 1. So you will have V1 plus and V1 minus. So V1 plus is the incident wave, V1 minus is the reflected wave. So at the port 2, you will have V2 plus and also V2 minus. So same as port 1, V2 plus is the incident wave and V2 minus will be the reflected wave. So here you will have the load Z0. So Z0 is the load. So here you have a mesh load because your Z0 over here is the same as Z0 over here because it is match. By definition of the S parameters, you will have V1 minus is equal to S11 V1 plus S12 V2 plus. And also you will have V2 minus is equal to S21 V1 plus S22 V2 plus. At port 1, the total voltage would be, so V1 is actually the combination of V1 plus and V1 minus. So here you have V1. So V1 is actually the addition of V1 plus and also V1 minus. So the total time average power at that port is comprised of two terms. So you will have P incident and also P reflected. So P incident is equal to V1 plus squared over 2Z0 and your P reflected is equal to V1 minus squared over 2Z0. Now, your Z0 is the same. So since port 2 is matched, the total voltage there would be, so V2, instead of V2 is equal to V2 plus V2 minus. So for a matched load, your V2 plus will be equal to 0. That's why you will have V2 is equal to V2 minus only. So for this circuit, the transmitted power is equal to, so P transmitted, provided that it is a matched load, so your V2 plus is equal to 0. This will give you V2 minus squared over 2Z0. So using all these results, we will consider ratios of these time average power quantities at each port and relate these ratios to the S parameter of the network. So now we want to relate the time average power with the S parameter. Now at port 1, the ratio of reflected and incident time average power. So there you will have P reflected over P incident is equal to V1 minus squared over V1 plus squared. So remember in previous lecture, we have S11 is equal to V1 minus over V1 plus when your V2 plus is equal to 0 because your port 2 is matched. Then you can substitute this to equation 8, where your P reflected over P incident will be equal to S11 squared. Because this one is V1 minus over V1 plus, which is the same like this one, V1 minus over V1 plus, but this one have squared. So that's why you will have squared over here. So this result teaches us that the relative reflective time average power at port 1 would be equal to S11 squared when port 2 is matched. Now we move on to port 2. So using the equation above, equation number 7 and number 4, the ratio of transmitted and incident time average power is, so you have P transmitted provided that your V2 plus is equal to 0 over P incident is equal to V2 minus squared over V1 plus squared. Now, with V2 plus is equal to 0, then you will have P transmitted over P incident. When your V2 plus is equal to 0, that will give you S21 squared. So here you can summarize that the relative transmitted power to port 2 equals to S21 squared when port 2 is matched. So this equation, the S21 squared and also S11 squared, provide an extremely useful physical interpretation of the S parameters as ratios of time average power. So note that this interpretation is valid regardless of the loss or even gain of the network. So if you have a lossless network, so your S parameters will be equal to S11, S12, S21 and S22. Should be unitary. So as a direct result of this, you will have S11 times S11 conjugate plus S21 times S21 conjugate is equal to 1. Or in other words, you will have S11 squared plus S21 squared is equal to 1. Also, you will have S12 times S12 conjugate plus S22 times S22 conjugate is equal to 1, or S22 squared plus S12 squared should be equal to 1. So this means that it is unitary. So this equation would be valid for all lossless two-port network. Right, next one we have generalized scattering parameters. So consider this figure over here. You have Z01 and Z02. So Z01 over here and Z02 at port 2. So notice that the impedance are different. They are not equal, yeah? So you will have P incident is equal to V1 plus squared over 2Z01, because this is the incident part. And then your P reflected is equal to V1 minus squared over 2Z01. P reflected refers to here, the one that is being reflected. So P transmitted is equal to V2 minus squared over 2Z02. So notice the difference, because the P incident and P reflected is using Z01, but your P transmitted is using Z02. It is unequal impedance. So consequently, your P reference over P incident, V2 plus is equal to 0. That will give you S11 squared, because you can just cancel the Z01. It is still the same, okay? But the problem lies for the P transmitted, because P transmitted over P incident, V2 plus is equal to 0. You will have V2 minus squared over Z02. But your P incident is V1 plus squared over Z01. So the values are different for this one. So to preserve the very useful interpretation of Sij squared as a relative time average power flow with matched ports, okay, the keyword here is match. So we need to redefine the S parameters when the port impedance are not equal. So that's why you will have this equation where your S21 is equal to V2 minus times with your the square root of Z01 over V1 plus times with the square root of Z02. Okay, this will give you AN. So AN is actually the wave amplitude towards the port that comes into the port. So you have AN is equal to Vn plus over the square root of Z0 n, and your wave amplitude that goes away, that come out from the port, that is defined as Bn is equal to Vn minus over the square root of Z0 n. So the inward and outward going wave amplitudes are related as B is equal to S times A. So the matrix, yeah. So you will have Sij is equal to Bi over Aj. Okay. This is what we call as generalized scattering parameters. What they do is they reduce to the regular S parameters when all port impedances are equal. So now you will have at the end your AN is equal to 1 over 2 times with the square root Z0 n, and then times with Vn plus Z0 n In, and your Bn is equal to 1 over 2 times with square root of Z0 n times with Vn minus Z0 n In. Okay, however, fear not, okay, the generalized scattering parameters is not much being used for this course. Okay, so this is just only for your information. Okay, so the topic is mentioned primarily to reinforce the relationship of S parameters to relative time average power and to present the wave amplitudes, which is the AN, the inward, and BN, the outward, which appear widely in the literature.